Hello students. In this chapter we are going to discuss some important tips related to some of the topics we discussed in the earlier two chapters, that is Solutions Part 1 and Solutions Part 2. Talking of solution, we can define its strength or concentration as the amount of solute in grams present in 1 liter of the solution. So the unit of strength of solution will be grams per liter. We can write it in the form of a simple formula where concentration or strength of the solution is equal to mass of the solute in grams divided by volume of solution in liters. So if we denote mass of the solute as W and volume of solution as V, we can write that the strength of the solution is equal to W divided by V. We discussed various methods of expressing the concentration of a solution. One of them was molarity. Molarity can be defined as the number of moles of a solute present in 1 liter of the solution. Now, suppose a solution is given to us whose volume is V1 and whose molarity is M1, and we dilute it to the volume M2, then we can find out the molarity of the resultant solution, that is M2, by using the equation M1V1 equals M2V2, where M1 and V1 are the molarity and the volume of the solution before dilution, and M2 and V2 are the molarity and the volume of the solution after dilution. Similarly, if we have three solutions whose volumes are V1, V2 and V3 respectively, and whose molarities are known to us, that is M1, M2 and M3 respectively, then on mixing those three solutions, the molarity of the resultant solution can be obtained by using the equation M1V1 plus M2V2 plus M3V3 is equal to Mr into V1 plus V2 plus V3. This V1 plus V2 plus V3 will be equal to the resultant volume, and Mr will be the molarity of the resultant solution. Normality can be defined as the number of gram equivalents of the solute present in 1 liter of the solution. As was in the case of molarity, we can find out the normality of a solution whose initial normality and volume are known to us, and we dilute it to a known volume. So if N1 and V1 are the normality and the volume of the solution before dilution, then we can find out N2, that is the normality of the solution, on diluting it to the volume V2 by using the equation N1V1 equals N2V2. Similarly, if we have three solutions, 1, 2 and 3, and their normalities N1, N2 and N3 are known to us, their volumes V1, V2 and V3 are mixed together, then the resultant normality, that is Nr, of the resultant solution can be obtained by using this equation, that is N1V1 plus N2V2 plus N3V3 is equal to Nr into V1 plus V2 plus V3, that is the resultant volume. We know that molarity and normality, both the terms are used to express the concentration of a given solution. So we can easily derive a correlation between them. We know that normality is equal to the gram equivalence of the solute present in 1 liter of solution, and molarity is the number of gram moles of a solution present in 1 liter of the solution. We calculate gram equivalence by dividing the weight of the substance by its equivalent weight, and we calculate the gram moles of a substance by dividing its given weight by its molecular weight or molar mass. So on correlating the two, that is normality and molarity, we can write the equation normality is equal to molarity into molar mass divided by equivalent mass. Now this term can be written as small n, so we can write, for the sake of simplification, that normality is equal to molarity into n. Now what is this n? This n is different in different cases. For acids and bases, this n is the basicity of acid. So for acids, normality is equal to molarity into basicity of acids. Similarly, for bases, normality is equal to molarity into acidity of base. And for oxidizing and reducing agents, normality is equal to molarity into change in the oxidation number. We can derive a relation between the molality of the solution and the mole fraction of the solute as well. We assume that a solution is composed of two components, A, which can be the solute, and B as the solvent. So the mole fraction of A, which will be donated by AXA, will be equal to Na divided by Na plus Nb, where Na is the number of moles of A and Nb is the number of moles of B. Similarly, AXB, that is the mole fraction of B, can be written as Nb divided by Na plus Nb. Now, when we divide AXA by AXB, Na plus Nb will be cancelled out as the common quantity, and we'll get AXA divided by AXB is equal to Na divided by Nb. Now, number of moles is equal to the weight of the substance divided by its molecular weight. So, we can write Na as Wa divided by Ma into Mb divided by Wb, where Wa and Wb are the weights of A and B respectively, and Ma and Mb are the molecular weights of A and B respectively. Now, if we multiply both these sides by 1000, we get Xa into 1000 divided by Xb is equal to Wa into Mb into 1000 divided by Wb into Ma. Now we can take Mb towards this side, so we get the equation Xa into 1000 divided by Xb into Mb is equal to Wa into 1000 divided by Wb and Ma. Now this is our formula for the molality of the solution. So we can write Xa into 1000 divided by Xb into Mb is equal to small m. Small m denotes the molality. Now, we know that Xa plus Xb is equal to 1, since the sum of the mole fractions of all the components of a solution or mixture is always unity. So, Xb can also be written as 1 minus Xa. On substituting the value of Xb in this equation, we get small m is equal to Xa into 1000 into, divided by 1 minus Xa into Mb.